So in this video, we are going to move on to our third organic family of our AS study, and that is halogenoalkanes. So we've looked at alkanes, alkenes, and now halogenoalkanes. And just like the other organic topics, we are going to look at naming them, their structure, their physical properties, how to prepare them, and then some of their reactions. So as usual, your specification points are on your first page. Over on the second page, then you have your CS definitions for this topic, and that may be worthwhile sitting down and learning these now, but we will meet each of these terms throughout the topic, but they are key terms that you need to be familiar with, that you could be asked for definitions of in your exam, and those are easy marks if you know those definitions really well. So just at the bottom of page 2, let's have a look at what a halogenoalkane is, and as the name suggests, halogenoalkanes are essentially alkanes where at least one of the carbon atoms has been substituted by a halogen. And we have actually met these before in our alkanes topic. Our reaction of alkanes, or radical substitution of alkanes, led to a substituted alkane, where that alkane had one of the hydrogens at least substituted by a chlorine or a bromine atom, and that was actually halogenoalkane. So where we made chloromethane in the first example that we looked at, that is an example of a halogenoalkane. So where at least one of the hydrogen atoms has been replaced by a halogen atom. The functional group of a halogenoalkane is CX, so the carbon that is bonded to your halogen. And there might be more than one of those within your halogenoalkane. But if there's just one of them, then here is your general formula. It is CnH2n plus 1 and then X. And if you think about the general formula of an alkane, it is CnH2n plus 2 for an alkane. And so what we've done is we've taken off one of those hydrogens. So the hydrogen is H2n plus 1 instead of 2n plus 2. And then we have replaced that hydrogen that's missing with an X, a halogen atom. So the X is the halogen atom, fluorine, chlorine, bromine, or iodine. Sometimes to simplify that down even further, and we will use this later on in our topic when we look at reactions, the general formula can be referred to as Rx, where R is the alkyl chain, so the carbon chain, and X is any halogen. So X is any halogen, R equals the alkyl chain. And remember, don't get confused by this term alkyl. You have met it before in your alkanes topic, just like a methyl substituent on a carbon chain. So for example, methyl chain would be CH3, ethyl would be C2H5, so the corresponding alkane minus one hydrogen, because then essentially that hydrogen has been replaced by the halogen. So let's move on to naming halogenoalkanes, and this is very straightforward. This is essentially the same rules as naming alkanes. Halogenoalkanes are named following the same IUPAC rules as substituted alkanes, and we'll have a look at what the name of the halogen substituents are. You're probably familiar with the names of these substituents from our alkanes topic, that last reaction of alkanes where we made substituted alkanes, things like chloroalkanes and bromoalkanes. So essentially it's the name of the halogen shortened down a little bit and ends in O for all of them. So an F atom substituent, a fluorine atom substituent, would be called fluoro, so like fluoromethane. A Cl substituent would be a chloro. Br is bromo and I is iodo. So as I say, halogenoalkanes are named following the same rules as alkanes. So the likes of find your longest chain, number the carbons so that the substituents are in the lowest possible carbon. If there's multiple substituents, put them in alphabetical order, all those sorts of things. But we'll talk through those as we do some examples on the next page. But just a little quick note before we do some of those examples about locant numbers or positional numbers, indicating where the halogen group is, or the halogen atom is. Of where we do need that and where we don't. So the first note is that all halogenoalkanes based on methane do not need a number before the halogen substituent. So in other words, they don't need a locant number. And why is that? That's because the halogen group only has one option of where it could be. It can only be on one carbon, because there only is one carbon. And so therefore we don't need to call this one chloromethane, it's just chloromethane. And even if there was two chloros there, we would just call that dichloromethane. It doesn't need to be one dichloromethane, because there is no other carbon atom that chloro group could be on. Second rule here, all halogen alkanes with up to 2 carbon atoms and 1 halogen atom also don't need a locant number for the halogen atom. And that's because, again, we would just, whatever carbon that halogen atom is on, we just consider that as carbon number 1. So even if we swap that round where this was H and this was Br, that would still be bromoethane. I'll take those out. You don't need to write that in case you confuse things, but there's no real option of where that bromine is. As long as there's only one halogen atom, even for substituted ethanes, you don't need a locant number. And then finally, rule number 3 here on the locant numbers is halogenoalkanes with more than one carbon atom and more than one halogen atoms. So in other words, ethane and longer, and more than one halogen atom. And those with more than 2 carbon atoms and any number of halogen atoms, even if we only have one, so propane onwards, do require a locant number. So let's look at each one of those rules in turn of where we do need locant numbers. So the first example is where we have more than one carbon atom. So we have an ethane as the end of our name because we've got 2 carbons and we've got 2 halogen atoms. So even though this only has 2 carbons, we do need locant numbers because we have 2 halogen atoms. So they could be both on carbon number 1, or they could be on carbon number 1 and carbon number 2. So you can see here they're both on the same carbon, so we would call this 1,1-dibromoethane. And so we do need a locant number here. Second part of that rule is that halogenoalkanes with more than 2 carbon atoms, so in other words propane and longer, and any number of halogen atoms do also require a locant number. So you can see here we've got a propane halogenoalkane and we've got an iodine group. So we've got this is called 2-iodopropane, because think about it, that iodo group could be on carbon number 1 or carbon number 2. So therefore we do need a locant number if our carbon chain length is any longer than 2. So let me do a couple of examples with you to help you practice these naming halogenoalkanes. I'll do a couple with you and then ask you to pause the video and try a few more. You will also meet in these examples your alkyl groups, things like methyl groups, ethyl groups, and so on. So if you wanted to take note of those at the top of the page, then you can do. And remember, where you have more than one substituent on your carbon chain, then you need to put those substituents in alphabetical order in the name, even if that means quoting a higher number first. So we'll see that in some of our examples here. So let's have a look at this first example. So the first step, as always, is find your longest carbon chain. That includes your functional group. So in here, that must include the halogen group, that halogen atom that's present. We then number the carbons. So the substituents are in the lowest possible carbon. So it might be helpful at this point to circle your substituents so that you spot them all, and then number your carbons so that it's on the lowest possible. So let's go right to left here. 1, 2, 3, 4. If we'd done left to right, the chloro group would have ended up being on carbon number 3, and that would be incorrect. So what do we call this? This is called 2-. Remember, numbers are separated from words with dashes. Our substituent is called chloro, and our carbon chain has 4 in it, so it is butane, 2-chlorobutane. Okay, let's have a look at this second example. So find your longest chain. It's 3 in length, so this is going to be a propane. I would circle my substituents at this point so that I can make sure I include all of them. Number your carbons so that those substituents are in the lowest possible carbon. They're both on carbon number 1. But now we have to put the substituents in alphabetical order. So it must be 1-bromo, -1-chloro, and then propane. Let me do one more with you, and then I will ask you to go on and try the rest yourself. So let's have a look at this next one. Again, find the longest chain first, that's most important. a step that you do at the start. I would circle your substituents so you spot them all. Number your carbon, so those substituents are in the lowest possible carbon. They're on 2 and 4 here, but you've got 2 bromo groups on carbon number 2. So let's number that as 2, so that our combination here is 224 rather than 244. So the lowest possible combination. Then what we need to do is remember to put these substituents in alphabetical order. So we have a bromo and an iodo. So bromo comes first. We need to show that both of those bromo groups are on carbon number 2, because one could be on 1, one could be on 5. There's lots of options of where these bromo groups are. So that's 2, 2. And then because there's 2 of them, it's dibromo. And then a dash to go to the locant number of the iodo group. So that's 4. 4-iodo, and there's 5 carbons in the longest chain, so that is pentane. 2,2-dibromo, 4-iodo pentane. So what I would like you to do now is pause this video and try the rest of these. You can try the rest of them on page 4 and 5. And then you can check through your names. Please do take time to check through the names to make sure that you're doing this accurately and haven't made any mistakes, so that you can try and correct those for future examples. So you can do them all and then check all the answers, or you can do one, then check it, do one, check one, and so on. It's up to you which way you want to do it. So pause the video now and try the rest of those examples. So let's have a look, but please make sure that you have tried these for yourself. So let's have a look at this next one. There's only 2 carbons in this halogenoalkane. There's a chloro group. And because there's only one halogen group, or halogen atom, and a chain length of 2 carbons, we actually don't need a locant number. We don't need to call this 1-chloroethane, because if we swapped it over to the other carbon, again, it would just be the same name, 1-chloroethane. So this just needs to be called chloroethane. And that goes back to note number 2 on the previous page. If you need to look back at that, is why we don't need a locant number there. Okay, next example, there's our longest chain here. We wouldn't want to put it up like this, because then our longest chain doesn't contain the iodo group, our functional group of the Ci bond. So there's the longest chain. Let's number it so that those substituents are on the lowest possible carbon. We have an iodo group and we have a methyl group. Iodo comes alphabetically before methyl, so we would call this 1-iodo -2-methyl, and then there's 4 carbons in the longest chain, so that is butane at the end. Remember, there's no spaces in these names, not even between the methyl and the butane there. They're all one word, so 1-iodo 2-methyl butane. Next one, hopefully you spotted that the longest chain was actually this one, because if you went straight across, then that would make that top group there an ethyl group, and you wouldn't have the longest chain. So the longest chain there has 6 in it, so this is going to be a hexane. We would have to number it left to right to get those substituents on the lowest possible carbon. Let's circle our substituents. So there's a methyl group, a bromo group, and another bromo group. Remember, think alphabetically is how we order these substituents. So bromo comes before methyl, so that's going to be called 2,4-dibromo 4-methyl-hexane. Next example, 1, 2, 3 carbons in the chain, so we are going to need a locant number. Anything more than ethane, any more than 2 carbons in the chain, we need locant numbers. So here's a substituent here, here, and here. Let's number the carbons from right to left to get those on the lowest possible carbons. Chloro comes before methyl alphabetically. So we have 1,2-dichloro 2-methyl propane. So remembering to quote both numbers of your chloro groups, and then dichloro because there's 2 of them, and then your methyl group is on carbon number 2. Then our final 2 examples, longest chain here is 5 in it. Remember, this group here at the bottom, what looks like a CH3 group is in fact part of the longest chain, so it's not a methyl group. where are your substituents? You've got a chloro, and a chloro here. So number that chain so that those are on the lowest possible carbon. So we need to include the numbers of all of those chloro groups in the name. So it's 2, 3, 3 trichloropentane because there's 3 chloro groups. And then lastly, longest chain could be one of 2 ways. It could be up like this, or it could be straight across. I probably find straight across a bit easier to see. Let's circle our substituents. We have a C2H5 group there, so that's an ethyl. And we have a CH3 group here, a methyl, and then a bromo group here as well. So number those so they're on the lowest possible combination of numbers, which is right to left. Think about alphabetically, and we've got our bromo, followed by our ethyl, followed by our methyl. Put them with their corresponding locant numbers. That becomes 2 bromo, 4 ethyl, 3 methyl hexane. And remembering to put your dashes in the right place as well, including all the dashes either side of those numbers. So hopefully you're happy enough with those examples. You could also be asked to draw the skeletal formula for halogenoalkanes, and that's done exactly the same way as before. If we go back to the top of this page, and we can do these examples, and you can go back to the previous page and do those as well. You probably find it easiest from the name. So if we have a look at this top one, the hexane is the longest part of the chain, so I would do that first. So there's 1, 2, 3, 4, 5, 6, and then put your substituents on. So you've got a methyl group on carbon number 4, so 1, 2, 3, this is carbon number 4, so that's what a methyl group looks like. Remember then your carbon, your extra carbon is there with 3 hydrogens attached to it. And then essentially for your bromo groups, you just put them on like this, so a bond and then a BR at the end. So that does not count as a carbon atom here, because you have written the formula of something else, a different group attached to the carbon chain there. So it is just your bromo group. And then we would need the same on carbon number 4 as well. It's getting a bit tight here, so it would look something like that. Or you could perhaps swap those round, so that your bromo group comes up here and then your extra methyl group is coming down, but either would be fine. If we have a look at the next one, longest chain is propane, so 1, 2, 3. We have a methyl group on carbon number 2, and then on carbon number 1 we have a chloro group, so it would just be written as that. And then we have another chloro group on carbon number 2, so we could put it even up there, and our methyl group becomes that one that's pointing down. So where our carbon atoms, they are here, 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 and here. Okay, so if we've got an extra line, but there's a different group attached to it, then that's not a carbon atom. So there's not a carbon atom here because we've got a chloro group there instead. So you could give those a go for the rest of the examples on this page and the next page. If you pause the video and try the ones on this page, I'll take you through those, and then you can go back and do page 4 as well. So let's have a look at these last two. So pentane is 1, 2, 3, 4, 5, and then you have got a chloro group on carbon number 2 and 2 chloro groups on carbon number 3. So it would look like that. They're probably not going to give you an example this complicated where there's multiple groups on the, halogen groups in the same carbon atoms plus maybe a methyl group as well. But the same principles apply to each one. Let's have a look at this last one. Lots going on here. So hexane 1, 2, 3, 4, 5, 6. And then on carbon number 2, you've got a bromo group. Carbon number 4, you've got an ethyl group, so that's up and across. Remember, 2 carbon atoms we're adding there, and then 3 methyl. So that would be that last one there. So if you go over to page 6, these are similar questions that you had in your previous booklets. So for the first question, you're asked to write down the molecular formula, structural formula, and name the halogenoalkane that is given to you. So if we have a look at 1A here, Molecular formula is just counting up the number of carbons, hydrogens, and in this case chlorines. So if you count all those up, you have got 5 carbon atoms. You've got 11 hydrogen atoms and you've 1 chlorine, so C5H11Cl. But that doesn't indicate where in the carbon chain our chlorine group is, so that's why a condensed structural formula, which is what you've been given, is helpful. And so part number 2 is draw the structural formula. So we'll be doing 1, 2, 3, 4, 5. We can see from our condensed structural formula that the chloro group is on carbon number 1, that end carbon. And then just fill up the rest with hydrogen. Okay, so you'd have to write hydrogens around all of those. Just ensuring, as always, that each carbon has 4 bonds. And then how do we name that? Well, we can see that our longest chain is 5 carbons long. So it's going to be a pentane. Our chlorine group is on carbon number 1, so this is called 1-chloropentane. What you could also do, which might be quite helpful, is practice drawing your skeletal formula as well. So for this one, your pentane is 1, 2, 3, 4, 5. And then your chlorine group is on carbon number 1, so we'll need to add the extra bond here and have the chloro group there. Remember, that's not us adding an extra carbon. Our carbons are just here, 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 and here. So that's 5 carbon atoms. We have to draw an extra line to be that extra bond to the chloro group because it's something different than hydrogen, but it doesn't add an additional carbon. So if there's a different atom or group of atoms at the end of a zigzag line, then that's not an extra carbon. It's whatever that group is that's bonded to the carbon that line is attached to. And obviously don't put your dots in, so I'll take those out. Number 2 then is just drawing your halogenoalkane from the name. Sorry, that's come with us here. You can ignore that. So if we have a look at 2A, you could try your skeletal formula with this as well. Iodoethane is just ethane is 2. And then our iodo group, you can put it wherever on carbon number 1. Doesn't need a locant number because if there's only 1 halogen atom here and a carbon chain length of 2, so if we swap that iodine to the other carbon atom, it would still just be iodoethane. It would be like essentially carbon number 1. So we don't need a locant number. Again, you could do your skeletal formula here. So ethane is a funny one. It's just this for our 2 carbons, 1 on each end of those. Obviously don't include your dots though. And then iodine on carbon number 1, you can put it either side, is fine. Need to draw an extra line to show the bond coming out to iodine, but then an iodine on the end of it. Again, that's not us adding an extra carbon. So have a go at questions 1 and 2 there of drawing halogenoalkanes, naming them, skeletal formula, and so on. And once you're finished that, I will put the answers of that up on Teams that you can check those, but make sure you have a go up at them yourself first.